Hello there, welcome to Maniac Math with Mrs. Carell. Make sure you put your name on your video notes page, and at the top where it says video number, write 5.1.2. Okay, remember, if it's in a green box, then you are expected to be doing it on your page, but you can see there is no green box here. Right now we're just going over some things. So, what does it mean when you have 10 times as much as something? Well, basically what it means is take something and make 10 of it. So right over here we have our one whole Hershey's candy bar, and you can see it's divided into 10 equal pieces, so each one is worth 1/10. Over here we have one piece of our candy bar, and we need to multiply it by 10. So what we're going to do is we're going to make copies of this until we have a total of 10 of them. Looky there, we have 10. So 1/10 times 10 gave us what? Well, it gave us 10 tenths. But wait, isn't that the same as 1 whole? It sure is. So if you look right here, if we multiply 0.1 or 1/10 times 10, it's the same as adding it up 10 times. So we have 10 ones here. Well, 10 ones equals 1/10. How do we write that? We write a 0. And we're going to put a little +1 up there and add all this up together. Well, we have a 0, so we're just going to put a 1 there. This decimal just drops straight down. Oh, look, there's 1 whole. Or we can multiply 1/10 times 10. 1 times 0 is 0. 0 times 0 is also 0. Oh, man, that's a waste, huh? I could just say 1/10 times 10, cross this off and drop it off here. Now all I have to do is this part. 1 times 1 is 1. 0 times 1 is 0. But where do I put that pesky decimal place? Well, it's one place in from the side. We're going to put it one place in from the side, just like that. And look, these are the same. Because we can ignore this first 0. It's still just 1 whole. So 1/10 times 10 equals 1 whole. So what we ended up doing was we took our number and we just moved it next door like this. And now we have 1 in the 1's place, and the 0, obviously there's nothing there, but we could put a 0 right here. So it just moved over 1. Multiplied it by 10, whole number just moved over one place to the left. Okay, we still don't have a green square. This is just us doing a little bit of learning before we get on to the problems. So we have 1, 2, 3, 4 whole candy bars, and we have 5 pieces out of another candy bar. So this is 4 and 5/10. 4 and 5/10. What we want to do is we want to multiply 4 and 5/10. Oops, I think I lost a couple of my tenths there, didn't we? I only have 3 up there. It's supposed to be 5. If we wanted to multiply 4 and 5/10 by 10, what do you think we need to do? Well, remember, when we are multiplying something by 10, we're just making 10 of it. So here's our original one up here, 4 and 5/10. And I've made it so that we now have 10 of them, 10 sets of 4 and 5/10. Well, how much is this really? Well, how about if we start by adding up all of the whole candy bars we have here. We have 4, 8, 12, 16, 20, 24, 28, 32, 36, 40. Okay, we've got 40 whole ones, but then we have all these half candy bars here. This 5/10 is half of the candy bar. How can we put all those together? How about if we take this half and put it over here? Look, there's another hole. And we'll put this one here. There's another hole. And this one over here, there's another hole. And this one, there's another hole. Now look, these two can go together. So if I had 40 whole ones already, and then I took all my half candy bars and put them together, so all these ones that say Hershey's, that's a total of 40 of them. 41, 42, 43, 44, 45, tenths originally, remember? Here, I put those other 2 tenths up there. 4 and 5 tenths. And then we ended up with 45 when I multiplied it by 10. I made 10 sets of it. So what did I do? I took this and moved it over. Look, now I have 45. Do you think we have a pattern here? I think so. Let's multiply 4 and 5 tenths times 10. We know it equals 45 because we just did that work over there. But let's see, how does it look when you do it as a multiplication problem? Because I don't know about you, but I don't really want to write 4.5 10 times. That's a lot of work. So I'm going to do multiplication instead. I'm going to get the same answer. All right, cross it off, drop it off. Now all we have is this, 45 times 1. What? I know my 1 times tables. 45 times 1 is 45. But where does that decimal go? It's 1 place in from the end, so it needs to go 1 place in from the end. Look at that. Same thing. I realize there's a 0 over here, but a 0 doesn't change the value of this when it's over here at the end past the decimal point. So all we did was we took this decimal and we moved it over a space. And we ended up with this. We took this decimal, moved it over a space, and we ended up with this. So we're going to focus on those patterns and do a few problems together. All right, so our first problem, you notice we have a green box and we have the number 1. So on your page where it says number 1, we're going to do 10 and 75 hundredths times 10. Do you remember the pattern? All we did was we took that decimal point and moved it over. Think about that. If I have 10 and I'm trying to make it bigger by multiplying it by 10, well, you know 10 times 10 is 100. So let's see what happens when I move that decimal point over to here. What do I get? I get 107 and 5 tenths. 107, that's pretty close to 100, right? Remember we said 10 times 10 is 100. There we go. Move the decimal over. Okay, problem number 2. So we have a green box. You should be doing this on your page. Our problem is 0 and 29 hundredths, and we're multiplying it by 10. Remember, we're making it bigger. So what was our pattern? We took the decimal place and put it where? Think to yourself. See if you can do this one on your own. Move it over. So now we have 2 and 9 tenths. So the number didn't change, just the decimal moved over 1 place to the right to make something bigger. Because if I have a candy bar divided into 100 pieces and I get 29 of those little tiny pieces, that's not very much. But if I have 2 whole candy bars and 9 tenths of another candy bar, that's almost 3 candy bars to myself. All right, problem number 3. 84 hundredths. How would I write that? Where do you think the decimal goes? Right here, 84 hundredths times 10. We're making it bigger. 84 pieces out of something that's divided into 100 pieces. Yeah, 84 out of 100 is a lot, but they're still teeny tiny little pieces. Let's multiply it by 10 so we can get something bigger. Where do you think the decimal goes to? Give it a shot. If you said this, you're correct. So the decimal moves 1 place to the right, 8 and 4 tenths. Okay, next problem is 2 and 6 tenths. How are we going to make 2 and 6 tenths multiplied by 10? What will we get? Remember our pattern. If I've got 2, if I just had 2 and I multiplied it by 10, that would be 20. I've got a little more than 2, so my answer should be a little more than 20, right? So, which way do we move that decimal? This way, and we get 26. The decimal just moved from here to here. Can you see that? Okay, problem number 5 is the last one we're going to do together, and then I'm going to give you some problems to try out on your own. I know you can do this. Well, let's see. Problem number 5 is, this is a big one, 631 tenths, hundredths, thousandths. So this is 631 thousandths times 10. So, 631 thousandths. Imagine you had that same one candy bar and you divided it into 1,000 tiny little bitty pieces. You get 631 of them. Huh. It's not very much. It's not even a whole candy bar. But if I multiplied that 631 thousandths by 10, what would I get? Let's move the decimal over one place right here, and what will we have? 6 and 31 hundredths. So that would be 6 whole candy bars and 31 hundredths out of another candy bar. All right, the next 5 problems you are going to do on your own. You have plenty of examples. Try your best because I think you got this. Problem number 6 is 1 and 20 hundredths times 10. Problem number 7 is 99 hundredths times 10. Problem number 8 is 8 and 37 hundredths times 10. Problem number 9 is 0 and 52 thousandths times 10. Don't get freaked out. It's the same process. Move that decimal over one space. And the last problem is 3 and 7 hundredths times 10. All right, get those last 5 problems done on your own. I know you can do this, and I'll see you next time.